Hello there, physics students. Today we are going to be going over the balanced forces introduction to common types of forces. This aligns with the document that we have, the balanced forces particle model. The front page is what we're trying to fill in right now. So you're filling this in on your notes, and I'm going to go over it in the slideshow here. So the very first thing that you see there is a force is, we're going to define it as an interaction between two objects, and it's generally a push or a pull. Okay, so that's the only thing you need to write down there, that stuff in red. Now, a little more in depth, those interactions can be either contact forces or at a distance forces. Contact means there's a physical, actual contact between them. At a distance, that would be kind of like if you have two magnets and you try and bring the two magnets together, they're going to push. And so they're even making a force even though they're not actually touched together yet. Okay? A force is a vector. It's a type of vector. It means it has both a magnitude and a strength. So a strength and a specific direction. When we add forces, they can cancel each other out, or they can have a final resultant amount. If you think about two people playing tug of war, if one person's pulling with 500 newtons that way, and the other is pulling with 600 newtons that way, the overall result would be 100 newtons this direction. Okay, so they can cancel out, and that's what the idea behind a net force is. There's not an actual force, it's just a combination when you add the forces together. We measure forces using newtons, which is 1 newton is 1 kilogram meter per second squared, and a single newton is equivalent to about the weight of 2 bananas, or I think it's 1 banana is 2 newtons. Now the types of forces, we're going to be filling this out. So the first basic type of force is, and the one that you've heard of, is the force of gravity. Another name for that is weight. Okay, so gravity or weight is a type of force. The direction of that force is always down or towards the center of that planet or star, and it's present anytime you're near a large object like a planet or a star. The symbol we'll use for this, it would be force of gravity, F of g. It's a subscript for the g, and the formula is mass times the acceleration of gravity. And the acceleration of gravity is 10 meters per second squared. The next basic type of force is a normal force. That is anytime you have two objects that are pushing on each other. When one object is sitting on the surface of another, or if you're pushing on something, anytime two objects are touching, then you have a normal force. It's always perpendicular to the surface. The symbol is Fn, and there isn't a specific formula. It depends on the physical situation and what's going on with the motion to be able to determine how much the normal force is. So you will be able to calculate it or logically deduce it, but there's not a formula for it. Friction would be when you have two surfaces sliding across each other, and it's always parallel to the surface, and it's always the opposite direction of the motion. So a capital F and then a subscript F, we have a formula where it's the coefficient of friction times the normal force. So the coefficient of friction depends on the surfaces. If you have wood on metal, or two different metals against each other, or your shoe on the concrete, any two surfaces will have a different coefficient of friction. There's actually a static coefficient of friction for objects that are not moving, and a kinetic coefficient when they've actually started moving. The next one we have that we're going to talk about is tension. Anytime we have a rope or a cable, or sometimes maybe a chain or something like that, we're going to say that there's tension, and we're going to call it's whenever the rope or chain or cable is stretched or taut, that's when it's present, and it's always whatever direction the rope is going. So we don't have a formula for it. It's going to depend on the physical situation. The symbol is F and then a subscript T. The last basic one we're going to talk about is spring force. This is going to be whenever you stretch or compress a spring, and it's whatever direction the spring is going. We do have a formula. It's equal to the spring constant K times X. So whatever the spring constant is, and that's different for every spring, you multiply that by how much the spring compresses or stretches, and that will give you your spring force. Okay? A couple other things. Newton's first law says that if there are forces acting on an object are balanced, then that object will stay at a constant velocity. Okay, so if it's balanced, you get a constant velocity. If it's constant velocity, the forces have to be balanced. The other half of that is if the forces acting on an object are unbalanced, then it's going to not have a constant velocity. Okay, so if it's unbalanced, it's either speeding up or slowing down or possibly changing directions. So that's Newton's first law. Newton's third law says that forces act in equal and opposite pairs. A force is always an interaction between two objects, and it can be described either way. If I push on a wall, then the wall is pushing on me at the same time in the opposite direction with the same amount of force. So I'm sitting on my chair, so I'm pushing down on my chair, but at the same time my chair is pushing up on me. Okay? One other thing is whenever we're looking at forces, we're looking at only a specific moment in time. You can add a couple of different moments in time, but it's kind of like you take out a camera and you do a quick instant snapshot, and when you take that picture, that's what's going on with the forces at that moment. That's different than any time we've been looking at our xt and vt graphs, because those are always over a longer period of time. Okay, so that's an introduction to forces. The next video is going to go through and show you how to draw system schemas and how to draw free body diagrams. Thank you.